In this video, we're going to explain what a block design experiment is. And we're starting with a picture here of a tub of optimum gold standard whey protein. The reason I chose this picture is that's going to be our treatment in this experiment. And I remember actually in college where it was a radio commercial that used to play, I swear, on repeat on a country station out in central Pennsylvania. And it always stuck with me when I hear gold standard whey protein. Um, anyway, what we're going to do today is we're going to look at the most effective way to carry out an experiment when you're dealing with something, in this case, with exercise and a supplement or nutrition. Okay, so real quick, let's say I wanted to first model the effectiveness of this whey protein using a completely randomized experimental design. So real quick, let's just kind of see what this would look like. So in a completely randomized experimental design, let's say we have, at the local gym, we have 30 subjects that we're going to use. And again, we're just seeing whey protein versus we'll say building muscle mass. All right, I want to see if taking this will build my muscles. Okay. Now, again, if we were doing a completely randomized experimental design, we always start with randomization, a random assignment into two groups. So we'll say 15 people and 15 people. And then we administer the treatment. So these 15 people, we'll say, have the whey protein for maybe 1 month or 4 weeks. And these 15 people are going to be our control. They're going to take, we'll say, the fake whey protein. That's our placebo. All right, same time interval, 1 month, and then we compare the results. Okay. And let's say that in doing this experiment, we find out that the people who took the whey protein did in fact gain much more muscle mass than the people taking the fake whey protein, and that would make sense, right? But in doing this design, we haven't really accounted for the biggest lurking variable here. So aside from taking the supplement of whey protein, the biggest lurking variable here that we haven't addressed is how often these people are going to the gym, right? How often are they working out, right? We'll just say frequency of workouts. So maybe I can't attribute the increase in muscle mass simply to the whey protein, right? Maybe it just so happens to be that these 15 people, okay, went to the gym 15 times that month, whereas these 15 people down here went less than 5 times a month, okay? That doesn't really help me in trying to figure out if this supplement helps building muscle mass. Okay, so what do I do? If we're completely ruling this out, which we are, that a completely randomized experiment is not going to work, what can we do? Okay, well, we can block according to that variable. Okay, in this case, that variable of frequency of workouts. All right, so similar to matched pair design, a block design, you don't start with randomization. You start with actually putting your subjects into categories. So let's say out of that group of 30, I want to try and eliminate this lurking variable of frequency of workouts into, let's just say I put them into 3 different groups. All right, well, we'll start with block. We're going to block our subjects. And again, we're going to put these subjects into 3 different groups. And in the first group, we'll say we're just going to go high, medium, and we'll say low. Okay. And high is, we'll say, more than, let me try and save some space here. We'll say 12 plus trips to the gym per month. So out of those 30 people, we'll say we have 10 of them that are in this high group. They've been to the gym more than 12 times. The medium group, we'll say, has gone between 9 and 11 trips. And then the low group, it will say is less than 9 trips to the gym. Okay, see how right off the bat I'm blocking my subjects based on that lurking variable frequency of workouts. And from there, I basically do the same thing I would as a completely randomized experiment. So again, I'm going to randomly assign a randomization. I'm just going to abbreviate here RA. Now remember, I started with 30 people in my group. So if I'm blocking, I would have 10 of those 30 here, 10 of those 30 here, 10 of those 30 in my medium group, right? So when I randomly assign, I'm going to have 5 people and 5 people. And it's going to take on that same nature in each one. 5 people, 5 people. And the last one too, 5 people. And 5 people. So you're seeing that it started to take on the similar nature of our matched pair design, right? And from here, once I randomly assign 5 people, okay, these 5, we're going to take the whey protein. These 5, we're going to take the fake whey. All right, we do the same thing down here. They're taking the whey. They're taking the fake whey. And the 5 down here, whey, and again, fake whey. All right, and then my very last step, just like we did with the matched pair, is I want to compare my results locally. So within the group, within the block, I'm not interested in how much muscle mass person A in this group gained versus person B in the medium group, right? I want to compare again locally. So we're going to compare results. Notice those 2 arrows are staying with the high group. So compare results. Down here, we're going to compare results. And then same thing down here, compare the results. Okay, let me try and zoom out here so we can see this whole thing in action. Zoom out. Do one more zoom out here. All right, and again, you can see very similar to matched pair. Once we block our subjects, if we take a look at this part of our experiment, it takes on the same nature as a completely randomized experiment. We just did it 3 different times. Random assignment, random assignment, random assignment, random assignment. Okay, so why do we do a block design? What's the importance here? Okay, it's because we attempt to control lurking variables, right? By grouping them into categories based on how often they go to the gym, we're trying to control that lurking variable of how often they work out.